Hey everybody, welcome to lesson number 5, Operations with Matrices. We're going to jump right into the lesson. So it's telling us that if two matrices have the same dimensions, and by n, it's possible for them to be equal. So our first example, we can see that we have a 2 by 2 and a 2 by 2, so we can consider them to be possibly equal. And what we'd be looking for is for each entry in the same corresponding position, those things would be considered equal. Right, so for this example, I would have A equal to -2. We can see B would be equal to 3, C equal to 16, and D equal to 1/2. Right, as long as they have the same dimensions, then each corresponding we can set equal. Right, that's going to help us with a lot of stuff, like addition, for example. When we're adding matrices of the same size, n by n, we just simply add the corresponding entries, and then we're able to make something that they are equal to. Right? So our first example, we're going to add this matrix, which is a 2 by 3, to this matrix, which is also a 2 by 3. So we're allowed to do this. And I'm going to show you the full step process for this problem. You don't have to do it every time. I mean, it's up to you how much you really want to show. Here we're going to add 1 and 4. Then we're going to do -3 and -3. And finally 2 and 0. That's the top row. And then we go down here. So we have each corresponding entry being added together. Right? And this is what we get for a solution. 5, -6, 2 on top, 0, 12, and 5. And notice, by the way, that it's still 2 by 3. Right? That's matrix addition. It's really as simple as you can possibly make it. Okay, so you have a problem down here. You can probably do exactly what we did up here without this step if you'd like to, and just jump right to it. However, I'm going to let you know, if you get things wrong, which it's kind of tough to do because it's just addition, but let's say you add wrong by accident. If you don't show this step, then there's nothing I can do in terms of partial credit on a quiz or a test. So just keep that in mind. Okay, but anyways, try this one down here. Pause the video and resume when you're ready to check. Alright, we know that we're going to end up having a 3 by 2 when we add these. So we're just going to add each corresponding entry. -4 and 12, that's going to give us 8. 5 and -6 is -1. 2 and -4 is -2. -8 and 3 gives us -5. 6 and 0 gives us 6. 6 and -6 gives us 0. That is the matrix that we're looking for when we add. Okay, so matrix addition, really pretty basic. A second operation that we can do with matrices is a scalar multiplication, in which case we're going to distribute to each entry in the matrix. It's going to remain the same size. So this is what we're going to end up seeing types of problems look like. Okay, we want to find -2 times matrix A, which this might be a different way of ever seeing these written out here. Okay, but now they're telling us that we're multiplying -2 as a scalar times some matrix, and then they explain what that matrix looks like. Okay, so pretty easy to do. We're just going to distribute -2 into each of these terms. Okay. Again, I'm going to show you this middle step, and later on if you'd like to skip it. That's completely up to you. Okay, so all I've done so far is distribute -2 to each of these terms. You can see that right here. And then we just perform. Okay, as you can see, everything has been doubled, and then the signs obviously change because we're multiplying by a negative, and this is the matrix that we end up with. Notice that it's still 2 by 2, just like what we started with. So scalar multiplication, pretty simple, right? Just multiply everything together. So we're going to do a little bit more exciting of a problem here. Okay, now they're asking us to find 3a minus 2b, and they give us these two matrices which happen to be the same dimensions. So we're able to do the we would call this addition, right? Addition of negatives, right? So here's what we're going to do. We're going to distribute the 3 to a first. We're going to distribute -2 to b, and then we'll add together. So that would be 3 times a, right? This is a's. And then we're going to add it to -2 times b. Okay, so let's see what that ends up looking like for us. 3 times 7 is 21. 3 times -6, -18. And 3 times 2 is 6. Plus -2 times 4 is -8. -2 times -5 is +10. -2 times 8 is -16. Now we have two matrices that we're just adding together. 21 plus -8, that is, why am I drawing a blank? 13, sorry. Let's see, -18 plus 10 is -8, and 6 minus 16 is -10. So this is the matrix that we end up with. Okay, so now we have a new problem for you to try out down here at the bottom. If you want to pause the video, try it on your own, and then resume when you're ready to check. Alright, let's see how you did. First we want to figure out what these new matrices look like. Okay, so we have everything set up. We just have to distribute, right? That's going to give us +6, +2, -2, and +4. Here we're going to end up with 15, 0, -5, -10. And now we're just adding. 6 and 15 is 21. 2 and 0 is 2. -4, -5 is -7. And 4 and -10 is -6. Right. Something else that we can do with scalar multiplication and matrix addition, we can solve, right? We can do algebra with matrices. I want to figure out the matrix that if we were to do two of those mystery matrices plus A, it's equal to B if these are what we're given for A and B. Okay, so we're doing an algebra here. And how do we normally do algebra? We solve for x. So let's do that first here. Okay, we're going to solve for x here. First, we're going to have to subtract a from both sides. So 2x equals b minus a, and then we're going to have to divide by 2. Now, instead of us dividing by 2, I'm going to rewrite this as multiply by 1/2. It's the same thing. So this is what we want x to equal. 1/2 times b minus a. So we are given b, we're given a. If we subtract a from b and then multiply by 1/2, we're in good shape. So let's do that. Here's the 1/2. b is 9, 9, -1, and 3. If we're subtracting a, it's kind of like adding the negative or the opposite of a. So if I'm doing negative, that's plus negative. That becomes positive, that becomes positive, that becomes negative. Right, I've just taken the opposite of a. Change all the signs. Okay. Now let's perform the addition. 9 and -5 is 4. 9 and +3 is 12. -1 and 7 is 6. 3 and -1 is 2. And then we just have to do half of each of these terms. Right? We distribute into each. So here we have it. 2, 6, 3, and 1. That is the matrix that x is equal to. So here you go. You can try one of them out on your own. Remember what we started with was solving for x, and then we performed whatever that happened to be down here. So try this one out, pause the video, and resume it when you're ready to check. Alright, so let's check this out. We're going to start off by solving. So we're going to add a onto both sides. So 3x equals b plus a. And we're going to multiply by 1/3 to clear out that 3. Oops. So here's what x looks like. 1/3 times b plus a. So we got to figure out what b plus a looks like, and then we're going to basically divide everything by 3. That's our goal. Let's see, we're doing, oops, -8, -3, 9, 7, -1, and 10. We're adding to it 2, 6, 3, -1, -8, -1. Okay, let's do the addition. -8 and 2 is -6. -3 and 6 is 3. 9 and 3 is 12. 7 and -1 is 6. -1, -8 is -9. 10, -1 is +9. Okay, so that's what happens when we add b plus a. Now we have to take 1/3 of that. So I'm just going to distribute. Basically, we're dividing everything by 3. So -6 divided by 3 is -2. 3 divided by 3 is 1. 12 by 3 is 4. 6 by 3 is 2. -9 by 3 is -3. And 9 by 3 is +3. This is what matrix X looks like. Okay, so you can do some algebra with matrices. That's why they call it linear algebra. Well, part of why they call it that. Okay, now we got one more thing that we can do with matrices, and that's called matrix multiplication. And it is not nearly as easy as scalar multiplication, because we're not just multiplying each term by one scalar, we're multiplying the entire matrix by another one, which is going to kind of change things around. Because we don't have to have them be the same size. In fact, if we have A as m by n and B as n by p, so these are completely different dimensions, except that we notice that our n values are the same on both of them. Okay, and we're going to end up with a matrix that's going to be m by p. So as long as these two dimensions, the column size of A and the row size of B match, we're going to end up with the row size of A and the column size of B. Kind of interesting. But the reason why is because this is how multiplication works. This is all purple, nothing that you have to write down. Okay, if we multiply and add all entries in the first row of A with all the entries in each row of column B, and then we're going to continue with the second row of A with all the columns of B until all rows and columns have been used up. Okay, it's not the easiest to explain written down, which is why I'm not having you rewrite it. It's really a process that you've got to see done. Okay, here's what happens. This is 3 by 2, and this is 2 by 2. So as long as these ones match right here for A and B, we can do the multiplication. Okay, and what we're going to result in is going to be a 3 by 2. Right, whatever these ones here, that's what a resulting matrix is going to look like. Okay, so I know it's going to be 3 rows. And this is how we do our multiplication. I'm going to take my first term of A here and multiply it by the first term of B. And then I'm going to add the second term in row A, which is 1, times the second term in column B, -1. Okay, that's what my first row, first column is going to look like. Now I need to do second row, first column. So I'm doing this row going this way, and then still the first column going down. So we've got 4 times 1 plus -2 times -1. And last row, first column again. So this is 0 times 1 plus 6 times -1. Okay, so that was first row with the first column. Now if I want first row, second column, which would be the solution here, I have to do these two terms with these terms. Alright, so here we go. 3 times 2 this time, plus 1 times 3. Right, because I'm using these two going down. Now I'm in the second row, so 4 times 2 plus -2 times 3. And last we have 0 times 2 plus 6 times 3. Okay, so again, the process, although it's probably not the clearest written up here, you're doing the first row, multiplying first column, that'll give you that first position. And you're adding the product. Okay, so that's where all these came from. Now all we have to do is actually just perform it. Right? 3 times 1, that's 3 minus 1. Here we're going to get 4 plus 2. And here we get 0 minus 6. Then we get the second column going down. 6 plus 3. 8 minus 6. And 0 plus 18. And now we just combine whatever these terms are. Right, 3 minus 1 for this first term. 4 plus 2. 0 minus 6. 6 plus 3. 8 minus 6. And 0 plus 18 gives us the resulting matrix, which was 3, by 2, just like we expect it to be. Okay, so that's how multiplication works. There's a problem right here for you to try out. I'll leave this open for you to use as a reference while you're trying this. So pause the video and resume it when you're ready to check. Okay, let's see how you did. First of all, matrix A is 2 by 3 and B is 3 by 2. So as long as these match, which they do, we're getting a resulting matrix of 2 by 2. So this is going to end up being smaller than both of these. It's kind of neat to think about. You're starting off with two larger matrices and you're going to end up with a smaller one. Let's see what this looks like though. First row, we've got 3 times 5 plus negative 1 times 0 plus 0 times 4. All right, I do this first with the first. That gives me the first position. Now I'm going to go down here and do these 3 with these 3. 4 times 5 plus negative 2 times 0 plus negative 2 times 4. Then I want this next column. I have to do the first row, second column. So now I'm doing all these. 3 times 1 plus negative 1 times negative 3 plus 0 times 2. Now I'm going to do second row, second column. 4 times 1 plus negative 2 times negative 3 plus negative 2 times 2. That's what all the multiplication and addition steps for each entry is going to look like. Let's simplify this a little bit. This is going to be 15. That becomes 0, and that becomes 0. That one was kind of easy. Here we've got 20. That becomes 0 and minus 8. This is 3 plus 3, and that's 0. Down here we've got 4 plus 6 minus 4. So here's what our final matrix is going to look like. That doesn't change. Nothing's happening to it. 20 minus 8 is 12. 6 here, and then let's see. Positive 4 and negative 4 cancel, so we get 6 here as well. So that's the matrix that you hopefully came up with, which is a 2 by 2 matrix. So that's matrix multiplication, and that's it for this lesson. That's all the stuff that we're going to go over for matrix operations. So if you have any questions, you can leave them on the comments, or better would be bringing to the class, because I don't really answer the things on the comment section as much as I do in class. So we got one more lesson, or 2 more lessons or something like that, and then we're done with this unit. So see you at lesson 6.